Okay, welcome back. In our week 1 part 2 video of Python Basics, we discussed all of the available arithmetic operators that Python 3.7 provides. Exponentiation, unary plus and minus, multiplication, division, modulus, and floor division. Modulus yields the remainder after division of one integer by another. So if I ask for 12 modulus 5, the remainder after division is 2. And if I use floor division, 12, and now I've made this same mistake again, I think. 12 floor divide by 5 is going to give me the whole integer part of that division. There are 2 5s in 12. With a fraction part left over, and so there I have the 2. So it looks like I'm getting the same value. Let me try saying, let's say 14 mod 5, which is going to give me a remainder of 4, versus 14 floor divide by 5, which will give me the whole number part of 2. So in other words, 2 times 5 is 10, plus 4 gets us back to 14. We've got the whole number part of the division and the remainder part of the division from floor divide and modulus. Then we also had the binary addition and subtraction operators. Numerical computations like this result in and involve either int values or float values. In all of these examples here, the operands are ints, and the results are also ints. If I have 14 divided by 5 without using floor divide, now I am going to get a float result, because division always results in a float. So 2.8 as a float is my result of that division. All right, well, onward ho, let's take a look at some additional low-level so-called scalar data types. That is the basic data types that we're going to need to use in our Python programming. In addition to the int and float data types that we've already talked about, we're also going to need to keep track of and manipulate strings of characters or sequences of characters. The data type name for this is stir. And we will also be asking true-false kinds of questions. Is the value that some variable refers to greater than 20, let's say? That will result in a bool value, which is either true or false. Sometimes it's possible for a variable to refer to no value, or it's possible for a function, to return no value. And in these cases, Python uses the special value none to keep track of this, to have a uniform way of keeping track of nothingness, if you will. Okay, so there are some other so-called scalar types that we simply won't use. We're going to restrict ourselves to worrying about int, float, stir, and bool, and the special value none. To keep track of strings, we can enclose a sequence of characters in single quotes, and that creates a string, or technically a stir object. All right, so single quote hello, close single quote, that creates a string, a stir of 5 characters. As an alternative to single quotes, we can also use double quotes. And Python, doesn't care which of these you use. They're equivalent. If I type double quote, WRLD, and double quote and hit the enter key, internally, when Python displays back to me the representation of that string object, it prefers to use single quotes. So it shows me world in single quotes, even though single quotes and double quotes are equivalent. Now, why do we have two different ways of quoting our character string, so-called literals here? Well, we can use single quotes to contain a string in which the string itself happens to contain double quotes. Here I have a string of 7 characters, double quote, HELLO, double quote, and I can enclose that in single quotes to cause the double quotes to be treated as ordinary characters within the string. Or the other way around, if I have single quotes in my string, I can use double quotes to contain my string. Here again, I have a string of 7 characters, single quote, WORLD, single quote. All right, so we can use either single quotes or double quotes when we write down a string of characters. Now, again, technically the name of this data type is stir, and what I'm writing here in these quote marks, either single quotes or double quotes, are what are called stir literals. But I can't bring myself to call these things stirs all the time. So I'm typically going to refer to them as strings. There are 2 of the operator symbols that we had previously used with numbers that we can also use with strings. And the meaning is sort of vaguely similar, but not quite the same. If I say single quote, hello, single quote, and then I use the plus operator and world in double quotes, the plus operator here is treated as concatenation. And the result will be one string containing HELLOWORLD. There is not a space put in between these when these 2 strings are concatenated together. All right, so the result of concatenating hello with world is hello world. The star operator is repetition. And so if I say something like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3, or repeated 3 times, all right, star is repetition, what I get is 0 through 9, 0 through 9, 0 through 9, 3 times in that string. Or if I were to say something like ABC space, let's say, times 4. This time I'm going to get the string ABC space repeated 4 times. All right, so I've got ABC space, ABC space, ABC space, ABC space. In addition to a pair of single quotes or a pair of double quotes, I can also, as it turns out, use triple single quotes or triple double quotes to define a string. So I can say quote, 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 single quotes in this case, hello, quote, 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 and that is a string of 5 characters. Or I can say double quote 3 times, and in this case world, and double quote 3 times. And there's the string world. Again, you might wonder, well, why in the world should I care about this? Why in the world would I need to use 3 single quotes or 3 double quotes to describe a string? Well, let's imagine that the string is a sentence in a conversation from a story. Maybe the part of the conversation is don't go there, she said. All right, this is the string that we want to represent inside of our program. Now, I can't put double quotes around this whole thing because I've got double quotes as part of the string. Likewise, I can't use single quotes around the whole thing because I've got a single quote inside here. well, I'm saying I can't use double quotes and I can't use single quotes. Actually, technically I can, but it's messy, and I'll get back to that. So what I do in this case is to use triple single quotes around the whole business. And so by using triple single quotes, I have now created a string consisting of the characters, double quote, capital D-O-N apostrophe T, all right, apostrophe for is the single quote, space go, space there, comma, double quote, space she, space said, period. And so that is a way of representing or describing or writing a string that in this case contains both double quotes and single quotes within the string. Now, an interesting thing is going to happen when I hit the Enter key here. When Python displays back the definition of the string, Python will not use the triple quotes, the triple single quotes. Python instead will put single quotes around this entire thing, and as a way of representing the literal single quote within this string, this is represented with a backslash before the single quote. So I could have typed that myself. I could have said quote, double quote, D-O-N, backslash, single quote, T, go there, comma, double quote, she said dot. I could have used the single quote with a backslash in front of it inside of the pair of single quotes to indicate that I want a literal single quote to be part of this overall string. But it's you know, it's a little bit of a mess to have to remember to type the backslash in front of the embedded single quote there. So it's more convenient for me when I'm writing code to use 3 single quotes instead. Okay. In fact, I could use double quotes. I could use double quotes to contain the whole string and say double quote, and then backslash double quote for the first double quote around don't, D-O-N. Now, because I've chosen to use double quotes here to contain my entire string, the single quote is okay, so I'll just type a single quote. I don't need the backslash there. Go there, comma. Now I need another backslash in front of this double quote. She said dot, single quote, double quote. Okay, so these 2 single quotes at the very beginning and the very end are containing all of the characters in my string literal. And because there are 2 double quotes within the string literal, I'm using a backslash in front of each of those double quotes to cause each of those double quotes to just be treated as an ordinary double quote. I hope you see that using triple single quotes or triple double quotes is simply more convenient here than having to remember to type these backslashes in front of the individual quotes that you might want to nest inside of some outer wrapping of single quotes or double quotes. Another thing that's useful about using the triple quote notation, either triple single quotes or triple double quotes, is that you can define a string that crosses multiple lines. Here we've got triple single quotes at the beginning of this multi-line string, stir, and triple single quotes at the end. If I say this is a multi-line string consisting of 4 lines of text, and there's my 3 single quotes. Now, in this implementation of idle, there's no prompt, there's no so-called continuation prompt to tell me that I am inside of the string that I am defining. If you use some other integrated development environment, it may or may not display some dots here, or some other indication at the beginning of what you're typing to indicate to you that you have not yet remembered to type your closing triple single quotes. But I'm not getting any kind of continuation prompt in this version of idle. When I hit the enter key, I get the representation of that multi-line string. Notice that within a multi-line string, or maybe I should just say within a string of, that you have defined somehow, this pair of characters, backslash followed by n, is how a so-called new line character is represented. The new line character is in fact just one character, but within the string it represents where, when the string is displayed, a carriage return should be displayed. Now, in all of these strings that I've written here, what's being displayed is what's called the representation of the string as you might type it in the source code of your Python code. To display readable output for some person to look at, let me jump ahead a couple slides here. What we're actually going to want to use is the print function to display output that a human user would expect to see. And actually, in order to make it easier to understand what's going on with print, rather than just typing these strings in manually as I've done, I should have set up some variables to refer to these strings. So if I say 4-line stir gets, and then I'm going to copy and paste this 4-line long string. Now, 4-line stir is a variable referring to that multi-line string. There is the internal representation of the string as I could have typed it if I had chosen to use individual single quotes rather than 3 single quotes on each end. When I print this thing, 4-line stir, what I see is the output that a human user would see on their computer screen. And in this case, you'll see that each \n, each new line character, gets displayed as a carriage return followed by a new line character. That is, the cursor zips back over to the beginning of the line and then drops down to the next line before the following characters, a multi-line string in this case, are displayed. So I've got this is and then a new line, and then multi-line string, and then a new line, and then consisting of 4, and then another new line, and then lines of text. Okay, so let me back up to where we were. Okay, so when we're defining strings, we can use either a pair of single quotes, or a pair of double quotes, or a pair of triple single quotes, or a pair of triple double quotes. We can find out how many items, in the case of a string, how many characters exist within a string. In general, we can find out how many items exist within some collection by using the len function. So if I ask for the len of the string literal hello, that string contains 5 characters. If I ask for the len of hi new line Joe, okay, now although I've typed 2 characters, \n, to represent a new line character in the string definition, in memory that's actually stored as a single new line character. The new line character is one of the so-called control characters. And so the len of hi new line Joe is actually just 6, not 7, okay? H is a character, I is a character, new line is a character, J, O, and E are characters. The len of double quote, double quote, double quote, double quote, double quote, double quote. This is a little bit silly, but I just wanted to illustrate. This is a legal representation of an empty string. I have 3 single quotes, followed by no characters, and concluded by, pardon me, I misspoke. I have 3 double quote characters, followed by no characters, and then concluded by 3 double quote characters. So that is actually an empty string. It contains 0 characters. Similarly, and more simply, 2 single quotes is empty. 2 double quotes is just a different way of writing the same thing. And of course, I can use quote, 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 quote as yet another alternative way of writing an empty string. All right, so these ones using the 3 double quotes and the 3 single quotes are frankly silly, but I just wanted to illustrate that this is consistent. You can use either a pair of single quotes, a pair of double quotes, a pair of 3 double quotes, or a pair of 3 single quotes to bound the characters within a string. When you use a variable to refer to an object, in Python, a variable is simply a reference to an object, and the variable itself does not carry around the concept of a data type with it. For example, if I say I get 123, what I've created there is a variable named I referring to the value 123, and the data type of 123 is int. All right, so I can use type to see what the actual data type of an object is. The type of 123 is int. The type of I, where I is a variable, is actually going to be the type of the object that I is referring to. All right, so the type of I at this moment is int. But if I say I gets 2.7, what happens in this case is that the variable I gets altered to refer to a floating point value of 2.7. So the type of I is now float, or more strictly, the type of the object that I is referring to is float. And it's perfectly okay for me to say I gets high in quotes, which means that I is now referring to a string object. Depending on what other programming experience you might have, this may be a new idea or a familiar idea to you. In lots of languages like C, Java, C++, C#, you have to specify the data type that a variable has when you introduce the variable into your program, and the data type of that variable is going to remain fixed throughout the execution of the program, or at least throughout the part of the code in which that variable has been specified. But this is not true in Python. In Python, a variable is simply a name that refers to an object, and you can use the same name over and over again to refer to different types of object within your program. Now, everything I've been doing so far has been interactive at the shell level. I'm typing some Python code, the code gets executed, and a result gets displayed. So I say I gets 1, 2, 3, 4. That gets executed. That does not produce a displayable result, but if I just say I by itself, I get the value that I refers to, or if I say I times 3, that computation is performed, and I get the value of that computation. I would like, though, to be able to save my code in an executable file that I can edit over time and make enhancements to and improvements to and fix bugs in, and execute that program file at will. So using idle, what I need to do is to launch the idle editor, and I can do that by saying File, New File. that pops up by default with a window that is too tall for you to see within the video window that I've created. So I'm going to change the size of this window and move it over to sit on top of the shell. Okay, so now I have the shell is still there, the shell window is still there, but I've also got this file editor window overlaying that shell window. And if I say File, Save As, I can give this file a name. Now I'm going to create a directory called Introduction to Programming with Python _online _2020. Okay, so ITPWP online 2020, that is my directory in which I want to store this file, and I'm just going to call this prog1. It may be difficult for you to see that on your YouTube screen, but I've given a file name here of prog1. The editor will automatically attach a .py extension to that. So this is going to create a file whose name is prog1.py. And I'll click Save. And you may or may not be able to see that in the title area of this window now, it's telling me that this file is prog1.py. And in particular, it's stored in the directory in the C drive users, jostland, itpwp online 2020, and then prog1.py. And in here now, I can start typing my Python code. But the Python code does not automatically run the way it does in the shell. If I want it to run, I have to actually go to the Run menu and select Run Module. At this point, there's nothing in the file, so there's nothing to run, but let me say a gets hello. And let's try, you may or may not be able to tell that there's a little star here on the file name indicating that this file has not yet been saved. So I'm going to need to say File Save, or I can just press Control S. I'm going to say File Save to save the modification that I've done to this file. An assignment does not produce any displayable output, so let me also say A, which in the shell would have displayed the value of A. And I'll save that. And now let's run this module. When I run the module, what's going to happen is that the contents of this file is going to be passed to my shell, and my shell will execute the sequence of statements contained within this file. And nothing happens. Okay. I get this restart message because whenever you execute a program, that will restart the shell to interpret that program, and that will also cause the shell to forget about everything else that it used to know. For example, I no longer have a variable named I because the shell was restarted. If I type I and hit enter, I get yelled at. Name I is not defined. But you'll notice that I didn't get hello displayed either. The reason for that is that the interactive shell automatically displays the result of an expression that you type in. But in a program, that's not the case. So in a program, if I want to have the value of A displayed, I need to use the print function. So let's go back to my program file. I'm going to use Alt-Tab to get back to that window. There we go. And instead of just saying A, let me say print A. All right, so now I'm defining A as a variable referring to the string hello, and then I'm asking to print A. I'll press Control S to save this, and I'll say run module. Notice, by the way, there's a shortcut key here as well. I can just press F5 rather than going into the run menu and choosing run module. But now, because I use the print function, I do get hello in my output from running my program. Let me go back to my program file, and this time let me press F5, and it does the same thing. It executes the code contained in my program, and the output is displayed on the user screen. Now, by default, the values that you pass to print will be separated from each other in the output with space characters. So, instead of printing just plain hello, I can print multiple values separated from each other with commas. Let's give this a try. All right, now in fact I'm too lazy to manually type this in, so let me turn my highlighter off. There, all right. And I'm going to now highlight, which will allow me to copy with Control C and paste this code with Control V over into my program file. Now, of course, if you're using a Mac, you'll have to do something else. If you are using some integrated development other than idle, you'll have to do whatever is appropriate in that development environment. But I have now modified my program file to contain 6 statements here, 6 statements of code. I've got the assignment, A gets hello, followed by print A. Then I've got fair gets 80, Celsius gets the Celsius equivalent of Fahrenheit. I'm printing just the Fahrenheit temperature. And then I'm printing the Fahrenheit temperature, followed by the string Fahrenheit is, and then the Celsius temperature, and then Celsius. Notice that I'm separating the 4 values in that final print function call using 3 commas. So we would say that this print function call is receiving 4 argument values. The value of the variable fair is the first argument value. The string Fahrenheit is the second argument value. The value of the variable Celsius is the third argument value, and then the string Celsius is the fourth argument value. When I save this by pressing Control S and then run it by pressing F5, I get hello from the first print statement. I get just the Fahrenheit temperature 80 from the second print statement, and then I get 80 space Fahrenheit is, let me highlight that correctly, Fahrenheit is, that's my first string argument, followed by the value of the Celsius variable, that's my third argument, and then the string Celsius as my fourth argument. So let me pull that program back onto the screen, and in fact let me shrink this program's text window a little bit. There we go. So now we can see the program, and in the bottom we can see here the output in the shell window that was produced when we executed this program. Okay, so I've got fair, and then where I have the comma, that comes out as a space. And then I've got Fahrenheit is, and where I have this comma, that comes out as a space. Then I've got Celsius, which is this number, followed by a space, and finally Celsius. Okay, so remember that if you want to see output displayed from a program, you must use the print function. You can't just give the expression or the name of a variable in order to see the value of that expression or the value of that variable. you can use what are called keyword arguments in the print function to modify the formatting of the output. One thing I didn't mention that I do want to mention now is that when you execute a print function, when you call a print function, not only does the print function display the arguments that you pass in, but it also automatically adds a new line character so that the next time some output is displayed, that next output goes on the following line. So when I say print A, not only did that display hello, H-E-L-L-O, but it also displayed a new line character so that the next time I called print, that second print function's output came on a separate line. Okay, so that so-called line ending character is something that we can alter. Here we're showing how to alter the argument separator character. The default argument separator character is the space character, but I can alter that by saying, all right, I've already got A defined to be hello, so let me add down here printing the value of A, then the string Bob, then the value of 11/3, then the Boolean value true. But instead of having these separated by space characters, let me separate these by comma characters instead. In fact, let me do that both ways just so that we're sure that we see what's going on here. Having some trouble with my copy paste. There we go. So first we're going to display A, Bob, 11/3, and true using the default separator, which is a space. Then we're going to display A, Bob, 11/3, and true using comma as our separator. And I'll press Control S to save it and press F5 to run it. And there we go. So here we have the output from the print statement that uses spaces to separate the value of A from Bob from the value of 11/3 from true. And then we have the one where we're using commas as the separator. Okay, and those are highlighted in red here on slide 11. Okay. We did use one example of a bool value in these print statements, in these print function calls. True means true, and false, with a capital F, means false. Now, those are the only legal spellings for the Boolean values. If you type true without the capital T, Python thinks you're attempting to access a variable whose name is true with a little t, and it says name true is not defined. Likewise, false with a lowercase f is also not defined. So true with a capital T is the special value, Boolean value true, and false with a capital F is false. As a convenience, and also for efficiency's sake, although in Python it's almost a little bit foolish to talk about these being efficient. In C and C++ and Java, they can be more efficient, but that's really not the point here. These assignment operators provide a convenient shorthand for very common mechanisms of modifying variables. If I have a variable, well, I do have a variable A, but unfortunately it refers to hello. So instead of these abstract examples, A star star gets B, that I have on slide 13, let me create a variable I. I doesn't currently exist, but let me create a variable I referring to 12. So there's I. I can say print I in my shell as well. And let me now say I times gets 2. Now that's the same thing as saying I gets I to the power 2. So the assignment operator star gets is simply an abbreviation for saying I gets I and then operator and some argument. So I'm squaring I, which is going to give me 144. And if I say I times gets, let's say 0.5, that's the same thing as saying I gets I times 0.5. What's the resulting data type of this going to be? I is 144, and I'm computing half of 144. So that'll be 72. Notice that this is a floating point value. Its data type is float. And the rule is that if I combine an int value, in this case the value that I refers to, which is 144, if I combine that using an arithmetic operator with a float, the whole computation is done in float and the result is float. So rather than getting just a plain 72, I'm going to get 72.0. And if I ask for the type of I, I'll see that I is now referring to a float. I can say I, let's see. I is now a float. All right, we haven't yet talked about how to convert a float into an int, but I'll just reveal that advanced knowledge right here. It's not really very advanced. I can make I be an int again by just converting I to an int by using int as a function. Now I refers to the integer value 72. Okay? And then these other assignment operators behave similarly. So slash gets is just shorthand for A gets A divided by B. Double slash gets is shorthand for A gets A. Floor divided by B, etc., etc. So I floor divide gets 7. Well, if I divide 72 by 7, that would be 10 and a fraction, but the floor divide throws away the fraction, and in this case, I will get the int result of that floor division, which is just going to be 10. Okay, so that was equivalent to saying I gets I floor divided by 7. Now, there are a couple of operator symbols that can be used with strings, and namely the plus for concatenation and the star or asterisk or times symbol. I dislike calling that thing the times symbol when I'm working with strings. But I can use these assignment operators, plus gets and times gets. All right, so I just got done saying I'm reluctant to call it times, and then I called it times gets. I guess it's just wired into my brain. Let's walk through these examples on slide 14. So in the upper example, I've got A gets 12. So A is now referring to an int. A plus gets 3 is the same thing as A gets A plus 3. So that's going to modify A to contain 15. A divide gets 5 is going to give me a float result, which does have a fraction of 0, but it is nevertheless a float. And if I multiply that by 4, I get A referring to 12.0. Now, if S is referring to HE, then S plus gets LLO is going to be the same thing as S gets S plus LLO. Consequently, since S originally is referring to HE and plus is concatenation, since we have strings on both sides here, I'm going to get this concatenated string HELLO, and S will be modified to refer to that concatenated string. So S now refers to HELLO. And of course, if I repeat S twice, S times gets 2. Now S refers to hello, hello. Okay, so that gets us to the conclusion of week 1, part 3. And we have a brief lab available which will give you some practice with these low-level scalar data types that we're going to use in this course, namely int, float for numbers, stir for strings of characters, bool for true false, and the special value none representing no value. You'll get a little bit of practice dealing with stir or string objects, how to define them, how to set up variables referring to them, how to concatenate and repeat them. You'll get a little practice using the idle editor and running programs from within the editor. We'll also give you some examples of variables as references to objects, and a little bit more about how to use the print function as well as len, and some practice with the assignment operators.